Okay, in this video we're going to have a little bit more of a look at completing the square. So to do that, I want to start with just looking at the factorising that we've already done. So let's consider this problem to start with. If I want to try and factorise x squared plus 6x plus 5, the first thing that I notice is that this is a trinomial. Okay, so for trinomials, look for a highest common factor to start with, and I can see that there isn't a highest common factor. So my next step is to try and find two numbers that multiply to equal positive 5, and the same two numbers have to add to equal positive 6. And I can quickly come up with, well, I can say that 5 times 1 is equal to positive 5, and 5 plus 1 equals 6. So I can factorise this expression by making it x plus 5, x plus 1. And that's all done. That's pretty straightforward. But now, what if I consider this problem? Very similar to the one above, but now I have a minus 5 or a negative 5 on the end. If I try and follow the same process for this equation, I want two numbers that multiply to equal negative 5 and the same two numbers that add to equal positive 6. Well, if I try negative 1 and positive 5, negative 1 plus positive 5, it doesn't equal positive 6, it equals positive 4. So that's not going to work for me. Alright, so let's try then negative 5 and positive 1. Negative 5 plus positive 1. Again, that doesn't equal positive 6, it equals negative 4. So it doesn't work either. And there's no other factors that I can try in this problem. So I'm kind of stuck. And it's not working for me exactly what I was, the way I was hoping it would. So the process of completing the square is a way that allows us to work through this type of problem. Okay, so let's start it again. That equation as we know it at the moment, x squared plus 6x take away 5 isn't working. And the part that's not working is the take away 5. So let's just move it over here out of the way and leave that out for a moment. What other numbers could I stick on the end here that would allow me to factorise it? Well, one possibility is I could make that number an 8. And to factorise this, I know that 4 times 2 equals 8. 4 plus 2 equals 6. So I could factorise it to be x plus 4, x plus 2, and then I still have a minus 5 on the end. Now that's all good, but it hasn't exactly made my problem any easier. So let's consider another possibility. And the idea of completing the square is to choose quite a specific number on the end here that makes this equation a little bit easier. And the number that I want to look at is actually 9. Now my reason for choosing 9 is that when I look for two numbers that multiply to equal 9 and the same two numbers that add to equal 6, what I end up with is 3 times 3 and 3 plus 3. Now the reason this is useful is because my factorisation doesn't end up with two different brackets. In fact, I have exactly the same bracket, so I can write it like this. Now that's pretty neat, because what I'm starting to see is that I'm also creating turning point form. But the question is, can I just add in a 9? Now, pretty obvious. I can't just add a number into an equation because I felt like it. But what I can do is, rather than just adding it, let's also take it away. So by adding the 9 and taking away the 9, I've essentially added the total of 0 to this equation. And if I've added 0 to the equation, I haven't actually changed the value of the equation at all. So this makes it all okay. So that 9 there, let's keep that going in my expression down the bottom here. I'd have minus 9 minus 5, and then minus 9 minus 5 at that step. And then finally, I can rewrite my equation as x plus 3 all squared minus 14. Now this is cool for a couple of reasons. Number one, it's turning point form. So that would help me draw a graph if I had to. The second reason is it's also the difference of perfect squares, because I've got a subtraction between my two parts. So I can keep factorising this now using the difference of perfect squares. And the way I factorise difference of perfect squares, if you've forgotten, is I have two brackets, one with a plus, one with a minus. I take the square root of each part to put into the equation. And then simplify that down. I get x plus 3 plus root 14 and x plus 3 minus the square root of 14. And now I've got two factors, and halfway along I also have the turning point form, which is useful for me as well. So that's the end of this video that's just exploring the process of completing the square. In the next video, I'll go into a little bit more detail about the algorithm or the steps that we take to complete the square more simply. All right, thank you.